Good morning, Applied Calc. I hope you're having a good day. I'm going to go ahead and do a second example for you with absolute mins and maxes and walk you through the process. Okay, so this is a continuation. This is just example number 2. We're going to do a cubic y equals negative x cubed plus 3x squared minus 1, and our x interval is going to be -1 to 3. All right, so this is calculus, which means you're not allowed to graph the original function, okay? We are going to first find our critical numbers, which is when the derivative is equal to 0, right? Which would be the potential maxes or mins. So I see the common -3x. So I get 0 and +2. Now, I am going to go to Desmos and just check my graph. Okay, and it looks like this. Okay, so 0. I'm going to click on those 2 points there, and I'm just labeling them so that you can see. All right, I'm not switching screens so you guys get a better view here, but this is what it looks like in Desmos, and all I did is I typed in this piece right here. Okay, now that I have the critical numbers, this is where there's potentially, right, maxes or mins on the original. So next, I am going to make my number line. Okay, so I'm going to put a little f of x. I'm going to do f prime of x and x. Now, I guess I could actually label this correctly. All right, so I'm going to go back and relabel this with y, and right, because this is what it is. This is y, and this is y prime. So I've got the 0 and the 2 for the x's, and y prime is 0 in these places. So now I'm going to go and check, okay, to figure out when it's positive and negative. So the first and third sections is when the y prime graph is below 0, so that means it is negative. And then in the middle section, okay, all right, y prime is above the axes, which makes it positive. Okay, so as I'm getting ready to make my conclusions, I'm going to write these sentences here just to kind of help you remember. So f of x is increasing when f prime is positive, which means increasing, okay? Right, because right here I'm drawing a picture of what f of x is going to look like. Okay, f of x is decreasing when f prime is negative. Okay, f of x has a horizontal tangent when f prime is 0. Okay, so that just gives me a little bit of an idea of what it looks like. So now that I have this, okay, step 3, okay, notice that this is more to do with the relative maxes or mins, okay, because it gives me those turning points. Step 3 is where I'm going to test the endpoints and critical numbers. Okay, so x and y, and notice that this is y equals, this is the original equation. Okay, and so we have an endpoint, a 0, a 2, and a 3. Endpoints and critical numbers. And we're just going to go ahead and plug it in. So we get, oh, that's a cubed. Okay, so we get 3. Okay, I'm going to plug in 0, -1. Plug in 2. Interesting. I see the same number popping up. Okay, plug in 3. Oh, interesting. So I see the same numbers. So right here, I'm just going to sort of check. So this one is 3. This is -1. This one is 3. And this one is -1. Now, right here, this is an absolute max and an absolute max. This one, which is a turning point, is also a relative max. This one, okay, endpoints can only be absolutes. Absolute min. This one is the absolute min, but it's also the relative min. All right, so let's write our conclusion statement. X equals 0 and 3. Okay. Absolute min is -1. Okay, and x equals -1 and 2. The absolute max is 3. Because look at this. It's okay to repeat the values if it's the same number.